A common practice by engineers when designing something new is to conceptualize and lay out ideas in a 2D layout sketch. Solid Edge offers a unique method for creating a virtual assembly of components. These virtual components can come from a pre-populated list of commonly used parts and subassemblies, or new component names can be entered on the fly. The Virtual Structure Editor allows you to build a virtual list of parts and subassemblies needed for a new design. Virtual assemblies in Solid Edge may also include some real 3D models in conjunction with sketch elements. The next step is to lay out all of these virtual parts and subassemblies into a 2D layout sketch. First, a design sketch is needed for the virtual lift arm for attaching the plow to the mounting frame. Solid Edge enables you to quickly generate sketch elements like circles, lines, arcs, and curves, and automatically creates connecting relationships between these elements as they're created. The lines are drawn quickly and easily by first establishing a tangent connection and then by making them tangent to the circle on the opposite end. Trimming can be accomplished by clicking on the elements you wish to remove or by simply dragging over the sections to trim away. Once a sketch of the lift arm component is created, the next step is to assign the sketch elements to the virtual lift arm component. This makes sure that once you publish your virtual assembly, the component will be positioned correctly relative to the other parts of the assembly. If there are multiple instances of a virtual component, the second instance can be simply placed once the sketch has been assigned to the first component. When a part is already designed, not virtual, Solid Edge enables you to create a 2D representation of that part or subassembly automatically in what is called a component sketch. This makes it very easy to add those representations into the virtual assembly and place them relative to the rest of the 2D layout. In Solid Edge, you can also add real 3D components and position them relative to the 2D sketch. Once it is in position, you can take advantage of the 2D relationships between the sketch elements and the 3D components to actually simulate the motion of the plow mechanism. Once everything is in position and you're ready to begin the real work of creating 3D models of your parts and subassemblies, you can publish the virtual assembly. This process creates new files on disk. In this case, the plow assembly has been completed by another design team, so you can just add it to replace the published plow assembly. Part of the published process is that Solid Edge automatically pushes the assigned sketches into the Solid Edge files it created on disk. This accelerates the design process of the lift arm part. You can reuse those sketch elements to actually begin to model synchronous features in the design of the lift arm. Solid Edge's synchronous technology enables you to edit two parts at the same time by simply dragging their geometry to shorten one part and extend the other. This is something no other CAD system can do. Now that we have the components fully assembled, we can simulate the same motion with the real parts. You may want to move the lift arm assembly to a new location. If you simply move just the assembly file, it would lose its links to all of its parts and subassemblies. Using Design Manager allows you to easily select what you want to move or copy to a new location and maintain its integrity. You can also use the Design Manager to rename assemblies and part files. Using the Design Manager for this task ensures that the related assemblies and parts maintain their links. Because the lift arm assembly was moved to a new location outside of the context of the plow assembly, the file could not be found. This is easy to fix by re-establishing the link in the new folder location. Design Manager makes it easy to move, rename, copy, and fix any broken links. In summary, I think it's easy to see how Solid Edge accelerates the task of going from concept to a 3D reality. Solid Edge. Design better.